Hello there, my name is Ramon, and today I'm going to be walking you through a tutorial on how to get started with Qdrant. We're going to be using the Python client for it, which is called Qdrant_client, and we're going to be running Qdrant via Docker. So I am assuming that you already know what vector databases are and that you are a little bit familiar with Qdrant, but you don't really know how to get started, what to do, and how do we really put vectors in it and start taking advantage of the nice components that Qdrant has to offer. All right, with that out of the way, we are here on the main website for Qdrant. Before we begin, we want to make sure we have a virtual environment set up. I'm going to be using Mamba, but feel free to use whatever you find most useful. So I'm going to say Mamba create -n. I'm going to give it the name of Q tutorial. I'm going to use Python 3.10. I'm going to add NumPy, Jupyter Lab, and a package called Faker. So while that gets installed, let's actually go to Qdrant. So Qdrant is a vector database powering the next generation of AI applications with advanced and high-performant vector similarity search technology. Not only does it allow you to search via semantically similar vectors to your query, but it also allows you to build a recommender system on top of a very powerful recommend API. So here you have a little bit more information about Qdrant. So I really recommend that you go through it and you read more of the things that Qdrant has to offer. Today, we're going to walk through a very narrow subset of the things that you can do in it. So we're going to go to the quick start section, which is going to tell us exactly what we need to get started. So the first thing is that we are going to pull the Qdrant image. I'm going to start by activating my environment. Then I am going to create a directory called Qdrant tutorial. I'm going to go in it. I'm going to pull the latest image of Qdrant. I already have the latest one. And then I'm going to run Jupyter Lab. I'm going to copy the URL to Jupyter Lab. And then I'm going to open up a new tab and head that way. Okay, so if we go back to Qdrant, in order to connect to it, we're going to need to run this command. But before we do so, we have to also install the Qdrant client. So let's go back here. Let's activate our environment again. And let's say pip install Qdrant client. We're also going to create a new Jupyter notebook, and we are going to call it Qdrant tutorial. Excellent. So now that we install everything we need, we're going to clear this out. We're going to paste our Docker command, and we are going to connect to Qdrant. Excellent. So as you can see, we have the latest version, which is v1.2.x, and we are ready to get started. So for our use case, what we're going to be doing is we're going to think through a scenario where we have a database or where we have 1,000 songs, and we want our users to be able to select one particular song and get the most similar ones, or we want to recommend them new songs or songs that they have never listened to based on the ones that they have liked and based on the ones that they have not liked. So we're going to make sure our recommendations are as far away as possible from the ones that they didn't like and as close as possible as the ones that they did like. So in order to create some fake data that represents our songs, we're going to use NumPy for that. But we're also going to connect to the container that we have running Qdrant via the Qdrant client that we just downloaded. So let's import all those libraries. We're going to import the models module because it has a lot of useful functionalities that we're going to need. We're going to import NumPy as NP, and then we're going to import a library that we're going to need, Faker. All right, so now we have the libraries that we're going to need. what do we need to do first? First, we're going to create a client to connect to Qdrant. We're going to call it client, and we're going to use the host is going to be set to localhost because we're running it in our computers. And then the port is going to be equal to 6333, which is the one that we use in our Docker command. Create our client. Then the next thing that we want to do is that we want to create a collection. So a collection is similar to what we will call a table in a transactional database or an analytical database. In those kinds of database, we search via SQL queries and those kinds of commands. In a vector database, the collections are a little bit different, even though they kind of seem similar to them. So you have points. You have a collection of points. These points have IDs, a vector, and a payload. The ID is a unique identifier for each vector. Imagine the ID representing an image, an audio file, a song, or a video, or even a document. Then the vector is the high dimensional representation of that piece of data. And then you have a payload. Payload is going to be like metadata about that data. So for example, you might have the artist that created the song that we are representing via vectors. You might have the country where that song was recorded at, the year where it was when it was released, the URL that we can use to go and access that song. And you can have all the information that you can think of. You can have anything. So with that out of the way, how do we create a collection? So we're going to use our client, and we're going to say create collection. We have to give it a name. So we're going to say collection name. We're going to call it my collection. And we're going to call it first collection. The next thing that we need is that we need to configure the vectors or give it a configuration file to the vectors. What are we going to have there? So what we're going to have is two things. We got to tell Qdrant the size of the dimensions of these vectors. Imagine that as the amount of columns that you're going to have in your database. And then we're going to tell it what kind of distance metric are we going to use to query the data when we query the database. So we're going to say models, vector params for vector parameters. We're going to say size. We're going to set it equal to 100. And then we're going to set the distance metric equal to cosine similarity. Okay, so we create our database. So how do we start filling up our collections with data? So the way we're going to do that is we're going to create fake data with NumPy. And remember, we're going to think that our use case is that we have a lot of songs, and we're going to represent each one of these songs with a high dimensional vector that has 100 dimensions. So each one of those dimensions is going to be, say, for example, the tempo of the song, the pitch of the voice of the singer, the genre, the length of. So each one of these vectors is going to be a characteristic of the song that it doesn't explicitly say is this characteristic, but is going to be represented as such. The way in which we get those high dimensional vectors is usually via the inner layers of a deep learning model. It can be, you can create these vectors in many different ways, but that seems to be the most useful one. And they're also often called embeddings. All right, so we're going to use NumPy to create a fake set of data that is going to represent our songs. We need to give it a low value of, we're going to say 1.0, and a high value of 1.0. So sorry, low value of minus 1.0 and a high value of 1.0. And then we got to give it a size. And the size is going to be 1,000 vectors of 100 dimensions each. And then we're also going to create an index for our collection, or an index of IDs. And then this is going to be a list with a range, the length of that dataset. We can also just put the 1,000 right away because we know it is 1,000. Okay, I have an error here, and it is a, size is equal. There you go. All right, so now that we have our data, we can fill in our collection. And we're going to do so with the client. We're going to use the method observed. And we're going to say, I want to observe data or vector or points into my collection called my collection. And then the points, for the points, I'm going to upload points in batches. So I'm going to use the batch method from Qdrant. And I'm going to say my IDs are equal to this index that I have here. And if you're curious as to what that data looks like, here are the first two vectors, and the first 10 elements or 10 dimensions. And then for the index, here are the last 10. So now we gotta give it the vectors. I'm gonna say vectors, data, to list. So notice something, Qdrant takes Python irrables. So we're gonna have to change the data type of our data, which is NumPy n-dimensional array, to a list. And then the index was already a list, so we can already upload that. So now that we have our collection filled up, how do we see it? How do we evaluate it? So one of the first things that we can do is we can retrieve elements from it. So we can say retrieve. We have to use the collection name. With the IDs, we can give it a list of IDs that we want to retrieve back. And then maybe even 500. So notice that now we have records back. This is what Qdrant is going to give us back. But that information in and of itself is not going to be that useful. If we want to retrieve the vectors, because we're going to be doing some data visualization with them by compressing them in 2 dimensions and then plotting them in a chart, well, we will have to tell Qdrant explicitly that we want to get the vectors back by making it equal to true. And notice that now we have a lot of information on our screen that maybe is not that useful. But where the power of this really lies is in getting something back that is useful for our users, because we want to give them semantically meaningful search results to their queries, or we want to give them a recommendation. So how do we do that? So first, we have to create a payload. And the way in which we're going to do that is with Faker. So let's instantiate a Faker object. Let's see what we can do with it. So you can see what it does is that it gives us random names, random last names, random first names, and then it gives us random addresses, but it also gives us random words, countries, years, URLs, and things that might be useful if we were dealing with a database of songs. If we have a song and we are uploading it into an app and we want to get the most similar ones, or we want to get recommendations based on our songs, then what we want to get back are probably things such as the name of the song, the artist, the year in which it was created, the country where it was released from, and so forth and so forth. So let's create a payload that contains all of this information. We're going to call it payload. We're going to create a list. A payload is a JSON object, or in the case of Python, it's going to be a dictionary. And it can contain any kind of data we want to put in, with some few constraints, of course. Like you're not going to put the vectors themselves in it if you can just have them already in the vectors. Or you're not going to put the exact piece of data, but maybe a URL to where your piece of data is at, like in an S3 bucket and so forth. So we're going to say payload dot append, and we're going to say artist. Make something, we're going to give it a name to the artist. Then we are going to have a song name. So what we're going to do with this one is, because it is a list of 3 words, we are going to combine them with a join method. There you go. And then for the artist, we already have it. So we're going to do URL song for the song. Then we're going to do year, and then we're going to do country. Year, URL, country. Let's see what we get back. So we're going to print the first three JSON objects. Notice how for our first song, we have Michael Chang as the artist. We have the song is Bed Want Style. That's the URL where we can go to listen to the song, the year in which it was released, and the country in which it was recorded. Okay, so now we can use again our observed method. And we can call our collection name. Then we can set points. We're going to use batch. For the IDs, we're going to use our index. For the vectors, we're going to use our data. And then for the payload, we're going to use the payload that we just created. Excellent. So that went through successfully. So now what do we want to do now? Some of the things that we're going to want to do with a vector database is semantic search. So let's do just that. So say, for example, so let me actually add a title here. Semantic search. So say, for example, we have the song of Ricky Martin called Living La Vida Loca. And we're going to create a NumPy array, just like before. But instead of giving it 1,000, we're only going to give it 100. And then we're going to make it a list right away. There you go. Okay, so if we wanted to semantically search for the most similar songs to Living La Vida Loca in our database, we would say client, add search. We will have to use the collection name. Then we will use a query vector, which is Living La Vida Loca. And then we are going to limit our results to, say, 10. So now notice that we got the 10 most similar ones to Living La Vida Loca. And one thing to really keep in mind, one thing to really notice is the score that we get for the similarity between the song that our user is searching for or is using to search and the ones that we are returning back. So this one, the very first one, is 37% similar to Living La Vida Loca. Remember, these are random numbers, but still, it's important to just keep this piece of information in mind because it's going to become useful when we turn the search results back around to our users and we give it back to them. Okay, so we got the Catherine Reynolds is the singer of this one. She's from French Guiana and so forth. So now, what if we wanted to, what if our users if we allowed our users to pick tags that they can use to filter the results with? So say, for example, we wanted to show only Aussie songs. So we will create a filter with the models module. And it's going to say must have. And then we're going to use a field condition. And that field condition is going to have a key that is going to be equal to country and a match that is going to be equal to the value Australia. Excellent. So now we can search in the exact same way. And I'm going to copy the search result. And then what we can do is right underneath or above query vector, we can say query filter. and add the Aussie songs filter. We're going to say, give me the top 3. And it seems like there was only, because these are random numbers, and random countries created by Faker, we can see that there was only one country with Australia in our payloads, and that's okay. We still got a match, but notice that is not that great of a match. So, and that's understandably so. Living La Vida Loca is a song by Ricky Martin, which is Puerto Rican, and Australia, and so Spanish song, and then or Spanish singer, and then Australia is an English-speaking country. So not that there hasn't been any songs in other languages coming from Australia, but just that it might just not be what we have in our database. Anyways, so now that we talked about semantic search, let's talk briefly about the recommendation API of Qdrant. So say, for example, we want to continue searching for these Hispanic songs. And what we're going to do is we're going to use the client, the recommend API in the same fashion as we did the search. We're going to use the collection name because that's where we're going to search at. And then for our query vector, we're going to use our song that we created a second ago. But then what we need to give it is, so imagine that our user is in our platform and every song that they like, they give it a thumbs up or they give it a heart. And every song that they dislike, they give it a thumbs down, or they just say, no, I don't like it. They eliminate it from their playlist so that they never see it again. In the same fashion, we're going to have a positive parameter where we can pass the ID of such songs that our user like. And what Qdrant is going to do is that it's going to filter the results for, it's going to find those which are most similar to the ones that the user have already liked, and then it's going to give those back. So imagine that it is the number 17, and that we song of ID 17, and that we want to limit the search result to 5 results. So now we have the 5 most similar ones that are to Living La Vida Loca, but taking into account that our user also likes this song. In the same fashion, we can also provide a negative vector and say, but my user actually didn't like song equal to 100, song equal to 444, and so forth. So what Qdrant will do is that it will try to find those which are furthest away in a high dimensional vector space, furthest away from songs of ID 100 and ID 444, and those which are closest to 17, and say we're going to put one more, say we're going to put 777 for our lucky number. There you go. Now we got the most similar ones that are closest to, in a vector space, to number 17 and 777, and those which are furthest away from 100 and 444. Lastly, the last thing that I want to show you is that you can also pass in a query filter on top of positive and negative results. And let's see, the way in which you do that. Say you put query filter, and you say models dot filter. Let's see, I'm going to use the same one that we use for Aussies. But because there's not that many of those, I'm going to say Dominican Republic, which is my native country, my home country. And we got to give it a comma here. And there you go. Now we have the most similar ones that come from artists from the Dominican Republic or songs that were recorded today. So with that, we conclude our tutorial. I hope you found this useful. So keep an eye out for other tutorials that are going to come up in the upcoming weeks and the upcoming months. And thank you very much. See you next time.